Hello, hello. Can you hear me? Can you hear me now? Okay. Sorry, I have a problem with my microphone. Let me get started again. Okay, guys. Once again, welcome to this last day of the course AI 1 of to designing and implementing Microsoft Azure AI solution. Today, we're going to see the last three modules of the course, which are detecting, analyzing, and recognizing faces, reading text in images and documents, and creating a knowledge mining solution. These are the last three modules of this course. Tomorrow, we're going to have this exam preparation, which is a little review of each module in order to get you prepared to the exam. Okay, so let's get started with with this with this module. Okay, thank you. Yeah, I already saw in the Q&A section that you already can can hear me. I'm going to share my screen right now once again because I don't know what is happening, guys. Okay. 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 I'm sharing my screen right now, and please tell me if you can see my screen and you can hear me loud and clear, please. Okay. Thank you. Now you can see my screen and you can hear me loud and clear. Thank you, guys. Sorry about that. I don't know what just happened with my. I don't know if it's my computer or whatever. Okay, let's get started with this module: detecting, analyzing, and recognizing faces. Remember, in this module, we have a little, some limitations. Probably you will have some issues in your laboratory because remember, we have some limitations using the Face API, the Face capabilities. This you for the responsible AI. Don't worry, I'm going to share you some articles talking about this. I already sent you a formulary in order to ask for the permission from Microsoft. And if you already lose this formulary, don't worry. At the end of the class or at the end of this module, I will send it again. Okay. So this keep in mind these guys, these modules, these three last modules are pretty short. So this probably we are going to finish a little early, but don't worry, we can use this time, I don't know, starting with the laboratories, or if you have any question about any service, any tip, I'm going to share some documentation, some actual samples from the GitHub. Uh, but okay, don't worry, we're going to use this time, okay, guys? So let's get started with this agenda for this module. The very first lesson we are going to see is detecting faces with the computer vision service, and The second one is using the face service. Okay, so let's get started with this detecting faces with the computer vision service. Now, remember, we have limited access to these these faces. So I'm going to share this link real quick, guys. In a sec, I'm going to send you in the chat or in my team chat, and I hope my colleague here is going to show you in the Q&A section. Okay, give me a sec. Is this log? Okay. Okay, this blog it is from Natasha Crampton, talking about the principles, the goals, the requirements, and the tools and practices from the responsible AI. And this is the why we can use freely the Face API. Okay, but don't worry, we have some free capabilities from Face, and we can make use of them. In this case, we have right here our capabilities that are um, requirement. Okay, so I'm going to show you this. Okay, and my colleague here is going to show you in the Q&A section. Okay, now, so we can use two cognitive services to build solutions that can find faces in pictures. The computer vision service let us find faces and image and tell us where they are by giving us a bounding box. Now, the face service can also analyze faces in a wide range. It is much more complete than computer vision service. Face detection, the face service can have the face detection with the bounding box and then analyzing of the all features of the faces, including the head pose, uh, presence of glasses, presence of blur, facial landmarks, occlusions, and so others. If you have any makeup, if you are smiling or not, um, we can use the face-to-face comparisons and checks and the face recognition. So once again, guys, remember, if you just want to know the face location, use computer vision. But if you want to have a wider range of ways than the computer vision service, please use Face API. This tells you the location, the attributes, the head pose, verification of the faces, and the recognition. You can use Face API in order to create your own custom module uh, from recognition people. Okay, now we need to talk about these considerations for face detection and facial recognition. Well, all artificial intelligence application requires consideration for responsible ethical use. Systems that rely on facial data can be especially troublesome. Here we are, we have the consideration for developing a solution that incorporates facial data. This could include, but are not limited to the privacy and security of the data. The patient data is personally identifiable, and should be treated sensible and private information. You should ensure that suitable protection data needed for model training inference has been implemented. We need to think about the transparency, guys. We need to make sure the users understands how their facial data will be utilized and who will have access to it. And we need to thinking about the fairness and inclusivity. We need to ensure that our face-based technology is not used to discriminate against people based on their looks or on just to unjustly target people. Okay, guys? Yes, keep in mind that. Now, in order to use the face detection with computer vision service, we'll we just need to call the analyze image rest function or the similar method in the SDK for our language programming or our preference. And then with faces as one of the visual features to be returned to recognize analyze faces with the computer vision service. In the case with one or more faces, the response will contain information about their location in the image, as well as the discovered person's traits, such as this JSON on the right. Okay, so here we have our REST BI or body, in this case the path of the image, or we can send a binary image data. This is going to take a lot of time, so keep that in mind, guys. If you use the binary image data, this is going to take a lot of time. And these are our response. The faces, the age, the approx age, gender, and the face of rectangle. This is, remember guys, using computer vision. Okay, let's continue. Now, using the face service. Now, the face service is capable of complete facial detection, analysis, and recognition. The face service provides functionality that we can use for the face detection. For each detected faces, the result includes an ID that identifies the face and its bounded box coordinates indicating its location in the image. We have the face attribute analysis, and we can return a wide range of facial attributes like the head pose in a 3D space like a pitch, roll, and jaw orientation. If the person has glasses, no glasses, reading glasses, goggles, the swimming goggles or sunglasses. If it is a portrait, what if it's a portrait in the photo, like in this case, the blur, it is low, medium, or high. We have the exposure. If the image is under exposure, if it's good exposure or overexposure. We have also the noise, if we have visual noise in the image, and the occlusion, objects obscuring the face. We also have the facial landmark location. These are the coordinates for the key landmarks in relation to facial features. For example, the eye corners, tips of nose, or the pupils. We can also use it in order to get a face comparison. We can compare faces across multiple images for similarity in order to find individuals with similar facial features. And verification this is in order to determine that a face in one image is the same person as a face in another image. And we have the facial recognition. Well, we can train a module with a collection of faces belonging to specific individuals and use this module to identify those people in new images. Okay. Let's continue. Now, when the face service finds a face, it gives an ID that stays in the service resource for 24 hours. Okay, once again, when this face API service finds a face, it gives it an ID that stays in the service resource. I mean, in the cloud. Okay, for 24 hours. This ID, this is a global unique identifier which doesn't tell anything about the person's identity other than what they look like. Okay, and we can see right here an example of these IDs. Okay, now while the detected faces ID is stored, new images can be used to compare the new faces to the identity to see if they are similar or if they have similar facial features, or just to confirm that the same person appears in two images, like like this. This is ABC hyphen 12345, and in this image we have this person with this ID, and once again person, or well, in this case, probably it is someone who has similar features on the faces. Okay. Now, this ability to compare faces without knowing who they belong to can be useful in systems where it's important to make sure the same person is there more than once, but you don't need to know who they are. For instance, we could take pictures of people as they enter and leave a secure area to make sure that everyone who entered leaves. Now, in order to train a facial recognition module with the face service, we need first create a person group. This defines a set of individuals which you want to identify, for example, your employees. Then we need to add this person to the person group for each individual you want to identify. After that, we need to add detected faces from multiple images to each person, preferably in various poses. These IDs of these faces will no longer expire after 24 hours, okay? And then we just need to train the module. The train module is stored in your face resource, and then the client application can use it to find people into pictures, check to see who a face belongs to, or look at new pictures to find faces that look like unknown face that keeps showing up. Okay, guys, you are going to do this in your lab, but once again, it is probably you will probably get some issues with this one. So, just I want to show you which laboratory is right now because just to you know, it is this one. Detect and analyze faces. This is the laboratory. Probably you will have some issues, okay? And you have right here the notes, the limit access. Okay. In this case, you are going to write some code in C Sharp and Python in order to detect faces in an image, and then train a module to recognize faces. Okay. So keeping that in mind, that guys, in this case, it is this one paste. It's this one. I have the API. Okay. Let me show you. I want to show you the. I think this. A sec here, really quick, guys. Take the normalizing faces. Wanna take a look. It is this one. 19 is the API. Yeah, we have the images. So we are going to analyze these images in order to get the face position, and using the face API, we're going to create the persons group, train our module, and here we have the the images in order to train this module, is, and after that we're going to use the train module to identify the persons. Okay, so keeping that in mind, guys, maybe you could get some problems using this laboratory, but don't worry. If you have any questions about the lab or something else, you can ask me in that session. Okay. So let's continue. Let's take our module review. Okay. Which of the following facial attributes can computer vision service predict? Once again, which following facial attributes can the computer vision service predict? The key it is right here, computer vision. Okay, computer vision. I will give you a couple of seconds, guys, and if you want to answer in the Q&A section, go ahead. If you don't worry, guys. I'm just giving you a couple of seconds here, and I will show you the answer. Okay, so let's take a look at the answer. Remember, computer vision just can have the location. Well, the location of this face and also the gender and the age. But in this case, the type of a glasses or occlusion, it is only for facial attributes. Face API, the face service. Okay, now you need to create a facial recognition solution that can identify named employees. Which service should you use? A couple of seconds here, guys. Okay, and the answer, obviously, it is face. Okay, now you need to verify that the person in a photo taken at hospital reception is the same person in a photo taken at a ward entrance 10 minutes later. What should you do? I'll give you a couple of seconds, guys. Okay, and here we have the answer. Okay, the answer will be verify the face in a word photo by comparing it to a detected face ID from the reception photo. Okay, guys, with this we already finished this module, so let's continue to the next one. Let me close this and let me open once again the next module. Okay. Okay, so now let's talk about reading text in image and documents. For agenda of this module, it is the first lesson, it is reading text with the computer vision service. After that, we are going to see where we are going to talk about the extracted information from forms with the form recognizer service. Okay. Now, we can use two APIs from computer vision service to read text. We have the read API and the API for image analysis. The read API, we can use this API to get a small to large amount of text from images and PDFs. This API uses more recent module than the OCR API, so it works better. Okay, right here. So this read API also can read both printed and handwritten text in English. It can read printed text in many different languages, but only can read handwritten text in English. Keeping that in mind, guys. Okay. And the first calls to a function returns an ID for an asynchronous operation. This ID must be used in a second call to get the results. Now, we have the second option. This is the API for image analysis. Okay. Um, Before this API for image analysis, we had the OCR API. As you can see, this one, it is already being deprecated. Okay, so these guys always use the read API, or you can use the image analysis. In the case of the image analysis, keep in mind, guys, that version 4 it is will add the ability to read text, which is still in preview. And we are going to use this API to get small amounts of the text from images or returns information about the context, such as the line, number, and position. Okay. Now, in order to use the read API, we need to call the read REST function, or the equivalent method from your preferred language programming. Then we need to pass the image URL or the binary data, and if you want, the language text it is written in English. You can pass the text is written in. By default, it is in English. If you set this in as default, okay? Now, the read function gives you an operation ID that you can use with the get read results function to get more information about the text that was read. Depending on how much text there is, you may need to use the get read text results function more than once to finish the job. Okay? Now, read API breaks down the results by page, then by line, and then by word. Also, the text value are included both at the line level and at the word level. This makes it easier to read whole lines of text if you don't need to extract text word by word. Let's continue. Extracting information from forms with a form recognizer set. Remember, if you have any questions, don't hesitate to ask in the Q&A section. And my colleague Fernando will gladly to answer you. Okay. Every industry, every day, uses forms to communicate information, to exchange information. So many people still manually extract data from formularies. So consider the following scenarios, uh, which a person must process from data. For example, consider when they submitting claims, when new patients are added to online management system, or when picking information from a report to present a stakeholder, adding receipt data to expenditure report, inspecting, I don't know, operation reports for irregularity. So people must manually go through from papers to discover important information and then manually re-enter data to record in the absence of AI services. Some may also be required to execute those activities in real time while working with a customer. Now, Form Recognizer is one of many services, cloud-based artificial intelligence services with these REST APIs and client libraries SDKs for incorporating intelligence into your application, guys. So this form recognizer extracts text, key value pairs, selection marks, and tables from documents using optical character recognition and deep learning modules. This OCR captures the structure of a document by drawing bounding boxes around the identified objects in an image. These coordinates of the bounding boxes are stored in reference to the rest of the page. Okay. Now, then, form recognizes service return bounding box data and other information in a structured format, along with the source files associations. Now, it's probably people must design deep learning modules and employ a considerable number of computational resources and undergo long model training times to create a high accuracy model from. Okay, these reasons may render a project impractical. So keeping that in mind, that the underlying modules of form recognizers, once again, the underlying models of form recognizers have been trained of thousands of form instances. The underlying modules allow us to extract high quality data from our forms with little, no model training. Okay? So the form recognizers also includes the following services: the document analysis module, that this take GPAG, PNG, PDF, and TI5 files as input and produce a JSON files containing position in bounding boxes, tables, text contents, document structure and selection marks, and so on. And also includes the pre-built modules. These modules identify and extract information from documents, photos, and return the extracted data in the form of a structured JSON output. Form Recognizer personally supports pre-built modules for the following forms: W2 forms, invoices, receipts, ID documents, and business cards. In order to show you this, let me, well, because each formulars, each forms has a lot of uses. Give me a sec. I'm going to show you right here. It is recognizer modules. Here. These are our pre-built modules: the W2, the invoice, the receipts, the ID, and you can see how they works. A lot of information about these formularies. Okay, let me send you these guys. You will you will use this. This. Okay, right here. I'm going to share it in my team chat, and my colleague Fernando will share you in the Q&A section. Okay. Thanks, Fernando. Okay. Now, let's take our module review. You have scanned a letter into PDF format and need to extract the text it contains. What should you do? I will give you a couple of seconds, guys, and then I will show the answer. Okay. Okay, so the answer it is use read API of computer vision service. Okay, now the next one. You need to build an application that summates expense claims, extracting the merchant dates and amount from scanned receipts. What's the best way to do this? Now a couple of seconds, guys, and then I will show you the answer. Okay, and the answer obviously is use form recognizer service. The last one, you need to extract only data from specific fields in cargo manifest. Using a form recognizer, what should you do? I'll give you a couple of seconds here, guys. Okay, and the answer obviously will be train a module with legal sample forms. Okay, this we already finished this module. As I said before, these modules are really short. Okay, now let's see our last module of the day. But before go to the this module, you have any question, you have any concern, please let me know in the chat. Okay, guys. So let's get started creating a knowledge mining solution. This module, in this module, we have three lessons. The first one is it is implementing an intelligent search solution, developing custom skills for enrichment pipeline, creating a knowledge store. Okay. Well, let's get started with this very first module. But first, in order to make choices, answer, increase, and function efficiently, all organizations rely on information. Take in mind that, keep in mind that guys. Most businesses' problems is not a lack of knowledge of information, but rather the difficulty in and extracting information from the huge number of documents, databases, and other sources which data is stored. Imagine this, the Magis travel. This Magis travel, you will see this Magis travel in your laboratory. It is Magis travel is a travel service that specializes in planning visits to cities all over the world. So over time, the organization has accumulated a massive amount of information in papers such as brochures, as well as client ratings of hotels. Well, this data is a great source of insights for travel agents and consumers as they plan trips, but the sheer volume of data can make finding relevant information to address the customer inquiry challenging. So, in order to overcome this issue, well, Margis Travel can create a solution that indexes and makes the document searchable. The solution allows agents and customers to query to find and uh, extract the information from relevant documents. So, Azure Cognitive Search is a cloud-based service indexing and querying a wide variety of data. So, as well as developing a comprehensive large-scale search solutions, we can use this cognitive search in order to, if we want to index documents and data from a range of sources, use these cognitive skills to enrich index data, and store extracted insights in a knowledge store. Okay, this is a lot of things we need to think about. You must obviously build an Azure, create an Azure Cognitive Search resource in our Azure subscription before we can develop an Azure search solution. And depending on the solution, maybe we may additionally require some Azure resources for data storage and another application service. Now, this cognitive search solution is made up of several components, each of which plays an important role in the extraction, the enrichment, indexing, and searching of data. First, with the data source. Most search solutions containing the data you want to search. Azure Cognitive Search supports multiple types of data source, including the unstructured files stored in a Azure Blob Storage container, tables in the Azure SQL database, or documents in the Cosmos DB or the Azure Cosmos DB. This Azure Cognitive Search can index data from several data sources, and the applications can also submit JSON's data directly into index rather than retrieving it from an existing data store. The skill set, well, you might simply index the data taken from the data source in a call it a rudimentary search solution. The amount of information that may be extracted is regulated by the data source. When indexing data in a database, for example, the fields of the database tables may be extracted, or when indexing a group of documents. While metadata such as a file name, modified date, size, and author may be extracted together with text content. Okay. Now, while a simple search solution that indexes data values collected straight from the data sources can be effective, modern application users' expectations have created a desire for more insight into the data. So, as part of the indexing process in the Azure Cognitive Search, we can use the artificial intelligence skills in order to enrich the source data with new information that can be mapped to index fields. And indexers skills are wrapped in a skill set. This describes an enrichment pipeline in which each step enriches the source data with insights gained from a distinct AI skill. The following are some samples or some information that maybe an AI skill can extract. We can extract the language in which document is written, the key phrases that might help determine the main themes of topics discussed in a document, the sentiment score that quantifies how positive or how negative a document is. So the specific location, the people, the organizations or landmarks mentioned in the content. And we have the AI generated description of images or image text extracted by optical character recognition. And we have the custom skills that you develop to meet specific requirements. Now, the indexer is the engine that powers the indexing process as a whole. It translates the outputs of the skill sets, talents, as well as the data and metadata values collected from the original data source to fields in the index. Now, when I is construct, it runs automatically and it can be scheduled to run at regular intervals or run on demand to add more documents to the index. Now, when you add new fields to an index or new talents to a skill set, you may need to reset the index before running the index again. The index is what can be used to search for things. It is made of a group of JSON documents with fields that hold values that were pulled out during the indexing. This index can be queried by client application to get information, filter it, and sort it. Okay? Now, each index field can be setting up with these attributes, with the attributes, with if the searchable, it is filterable, sortable, faceable. Faceable means that fields can be used to determine values of the facets or the also called users interface elements. Okay, and if the fields are retrievable or not. Now, how the enrichment, like, sorry, how the enrichment pipeline works. The indexing process works by creating a document for each indexed entity. During this indexing and enrichment pipeline, iteratively builds the document that combines metadata from data source with enrichment fields extracted by cognitive skills. Now, we can think about this of each indexed document as a JSON structure, which initially consists of a document with index fields you already mapped to have mapped to fields extracted directly from the source data like this. Let me point, show you the pointer. In this case, we have the document, the metadata, author, the content, and the normalized images. Now, when a document data in source contains images, we can compute the indexes to extract the image data and place each image in a normalized image collection, like this. We have the normalized images. And in the normalized images, we can have as image 0, 1, 2, 3, 4. Okay. Now, normalizing the image data in these ways enables us to use the collection of image as an input for skills that extract information from image data. Each skills adds fields to the document so for example, a skill that detects the language in which a document is written might store its output, a language field like this. Sorry, I don't know what is happening with my mouse? Okay, the pointer. Okay, like this. And then, if the document is structured a hierarchy and the skills are applied to specific contexts within the hierarchy, enable us to run the skill for each item at a particular level of the document. For example, we could run an optical character recognition skill for each image in the normalized image collection in order to extract any text they contain, like this. Okay. Okay. Now, the fields in this document, for example, in this document, this skill, uh, at the end of the pipeline are mapped to index fields by the indexer in one or two ways. We can have the fields extracted directly from data. Okay. This mapping can be implicit or explicit. What does that mean? Implicit means that the fields are automatically mapped to fields with the same name in the index. Explicit meaning means that a mapping is defined to match a source field to an index field. Often, the renamed field to something more useful or apply a function to the data value as it is mapped. Okay. And the other way is the output fields from the skills and the skill set are explicitly mapped from the hierarchical location in the output to the target field in the index. Let's continue with the next lesson. Yes, yes, okay, let's talk about the developing custom skills for an enrichment pipeline. Okay, now we can utilize Azure Cognitive Search predefined skills to considerably improve an index by extracting more information from the source data. However, there might be times when we have special data extraction requirements that cannot be addressed by existing abilities, and we probably need to use the bespoke functionality. For example, we can integrate the form recognizer service to extract data from forms. We can use or we can consume an Azure machine learning module in order to integrate predicted values into an index or any other custom logic. These custom skills can be implemented as a web-hosted services like Azure Functions. This enables the needed interface for integration into a skill set to handle these scenarios. Okay, so keeping that in mind, guys, if you need the custom skills, you need to choose the Azure function in order to use. Okay, now our custom skills must be implemented to this well, must implement the expected schema for input and output data that Azure Cognitive Search skill sets demand. Now, the input schema for a custom skills is a JSON structure with a record for each document to be processed. Each document has a unique identifier and a payload of data with one or more inputs, like this on the left. We have values, the record ID, the data for each record ID. Now, the schema of the results your custom skills gives back is the same as the schema. It is assumed that for each input record, the output will have a record with either the skills results or details about any errors that happen. Okay, it's the same. Just we need well, our output will add these errors or the warnings for each schema. Now, in order to add a custom skill to our indexing solution, we need to use the custom.web API skill. This skill and type it as a skill set. Okay. Now the skill definition must specify the URI to your web API endpoint. This including the parameters and headers if it's necessary. If it's not, you can ignore it. We need to set the context to specify at which point in the document hierarchy the skill should be called, the assign inputs and from existing documents fields, and store output in a new field. Optionally, we can specify in the target field name. Okay, now let's talk about these knowledge stores. Even though the index might be considered as the main result of indexing, the enriched data it contains might be useful in other ways as well. For instance, since the index is mostly a collection of JSON objects, each of which represents our index, it might be useful to export the objects as JSON files that they can be added to a data orchestration process using tools like Azure Data Factory. Now, you probably want to turn the index record into a relational schema of data, of tables. So we can use tools like Power BI, Microsoft Power BI to analyze and report on them. And the indexing process, we probably have taken images from documents that were embedded in them. So you may want to save these images as files. Now, Azure Cognitive Search help these situations by letting you define a knowledge store in the skill set that hosts your enrichment pipeline. The knowledge store is made up of something called projections of the enriched data. These projections can be JSONs, tables, or image files. When an indexer runs the pipeline to create or update an index, the projections are made and saved in the knowledge store. Now, how can you use these projections? Well, the document structures made by the enrichment pipeline during the indexing process are used to figure it out what data will be stored in your knowledge store. Each skill in your skill set builds a JSON representation of the enriched data for the documents being indexed. And we can keep some or all of these fields in the documents as projections. When indexing is done in small steps, it creates a complicated document with all of the output fields from the skills in the skill set. And then this can lead to a schema that is hard to work with and has groups of simple data values that are hard to map well a format JSON. Now, in a knowledge storage, it's common to use the something called sharper skill. To make a new field with simpler structure for the fields, you may want to map to projections, and this makes it easier to map these fields value to projection. just like this. We have right here our mapping using the sharper scale, inputs, or the name of the document, the source, context, and the output. Okay, now to specify the knowledge store and the projections you want to build in it creates we need to create a knowledge something well sorry, we need to create the knowledge store object in set that this defines the Azure storage connection string for the storage account. Um, and this is where we want to construct this projection as well as the projection definitions. Depending on what you wish to store, you probably can build objects, projections, table projections, and file projection. However, keep in mind that you must define different projection for each type of projection, even though even though each projection contains list of for tables, files, or objects. In a projection definition, projection types are mutually exclusive. Therefore, only one of the projection type lists can be populated. In all three types of projection, you must include one of each. Okay? So, now, okay, guys, as I said before, these modules, these last three modules are showing. So, let's take our module review. So, you want to enrich an index by extracting any geographical location mentioned in the source data. Which built-in skills should you use? I will give you a couple of seconds, guys. Okay. Okay. You need to use entity recognition. Remember, entity recognition will, as the language service, remember, entity recognition can recognize these places, locations, if it's talking about persons, if it's talking about products, etc. No. You have implemented a custom skill as an Azure function. How can you include the custom skill in your indexing process? Okay. We need to add a web API skills to a skill set. And the last one, you want to create a knowledge store that contains JSON representation of the extracted data. What kind of projection you should define? Should you define, sorry. And the answer obviously will be object. Okay, guys. So now we already finished these three modules for today. Let me take a look if we have any question. Okay. Is, so is everything answered? Okay. The last question: how would you explain the difference between a knowledge store and index? Okay. Thank you, Fernando. And as Fernando said, John, uh, the knowledge store is something created by the cognitive search enrichment pipeline, and this will store contents in tables of the containers in the Azure storage. Okay, and the outputs from this enrichment pipeline can be a search index or a projection in a knowledge store. Meanwhile, the index think as a searchable content. That's all. This is makes available to the search engine for indexing the text search and filtering some queries. Okay, that is the main difference. Okay, guys, as I said before, these modules are real short. So let me know. Do you have any question? Do you want to take a look at once again, another module, a little review? Please let me know in the Q&A. Meanwhile, I will share you in the Q&A section and the GitHub in order if you want to to take a look in some Azure samples. Give me a sec. Uh, uh, where is it? Here we have. Okay, I'm going to show you this. I just wanted to let you know. If you want to take a look about, I don't know, services, custom vision, and so on, you can go through this GitHub repository uh, and take a look. I don't know, for example, if you want to take a look for vision, just search right here, and we have. Okay, John, can the output of a enrichment pipeline be sent to both index and knowledge store? Of course, it doesn't need it to be one or another one. Can be sent it to both of them. Okay, right here. So let me show you this, guys. This is going to help you, and I'm going to share you this AI. Okay. First, the Azure samples. Any query? Uh, where is it? How can I add a question? Okay. Azure samples repository. And here we have the actual learning path. Everything I talk about in these last 4 days, it is right here. Everything it is right here. And probably you may find more information, more theoretical information right here. And you, for example, if you want to see this one, provision and manage Azure Cognitive Services, you will find exercises like can take like up to 5 to 30 minutes. For example, this one, these cognitive services, and these are the labs, the laboratories that you already done in these last days. But if you want to continue tracking or continue practicing in this one, you can launch these labs. And for example, let me take a look. For example, in this, I think it is this one. Here we have a lot of exercises. No, let me take a look. Monitor cognitive services. I think it is this. No, sorry. Let me go back. Here, the last one. I think it's this one. Okay. As you can see, in the implement knowledge mining, cognitive search, we have more modules. For example, if you want to use a cognitive search using the use data factory, you have an exercise as well. So you can set up your development environment. You need to install, in this case, VS Code, Netcode 3.1. So you can continue, keep tracking, keep practicing using this learning path. So I'm going to show you this learning path as well. This is where you're going to schedule your exam right here when you receive this. Um, you receive it in your at the end of this cloud week. You will receive, if I'm not wrong, in 10 business days. You will schedule your exam. But right here, it is the learning path. Okay. I'm going to show you this, guys. Uh, AI 102 learning path. Okay, some of exercise here I could not launch in my trial subscription. I could not train object detection and recognition models. In the left subscription, they were fine. Okay, that's correct. The trial subscription has a limit, some limit options, and in the lab subscription they work fine because they don't have any limit. For example, let me show you. In my portal Azure, I already have some description. This is a Visual Studio Enterprise subscription. This is I don't have any limitation. Well, just the limitation is the billing or my credit in this case, but you don't have any limitation right here. But the free trials or the trials or the free services, you have a lot of limitations. So keep in mind that, guys. So I think, if I'm not wrong, you can still use laboratories like up to December. Let me take a look. Give me a second, guys. I'm not sure how many times you have in your labs. A sec. Let me take a look right here. Where is it? Okay, right here. They have a month. Yeah. Thank you, Mata, Fernando. You have up to December. You have a month. Okay, guys. So you can continue using these laboratories, and if you lost this subscription, well, you need to create a free trial. Okay. So, okay, guys, I already sent you this learning path, the Azure samples, and okay, that's all for me in these modules. Tomorrow we are going to have this exam preparation. It is a little review of each module in order to get ready in the exam. But you already done it, guys. So we can use this time to to continue with the labs, guys. So please go to the laboratories, and when we finish this session, we can continue to the laboratories in the next session in the Q&A and laboratory section. Okay, guys, thank you very much. I hope you enjoy this theoretical part, these sessions, and the demos as well. And well, I'll keep around, obviously, right here. But if you have any questions, please let me know in the chat in the Q&A section, and I'll be right here, guys. So I will share my screen, share my this slide in order to let you know that you can continue with the labs right now. You have any questions? And thank you once again, guys. Have a great day. Stick around right here. You have any question? Once again, please let me know in the Q&A section if you want to take a review of some more documentation or whatever. Okay, guys? Thank you very much.